So here we go with 18.4a. We've got three new trig functions. Sine, cosine, and tangent are not the only ones that there are. So we have these things called reciprocal functions, which are cosecant, secant, and cotangent. And we're going to focus on those in triangles for right now. But I need to show you how they're paired up. First off, sine of theta. We know that sine from our favorite word, SOHCAHTOA. I'll write that up here. SOHCAHTOA. That sine is opposite over hypotenuse. Well, sine has a reciprocal, which is hypotenuse over opposite, which is just flipping your sign upside down, and that is known as cosecant. We abbreviate that one as CSC of theta. Sine we know is abbreviated as SIN theta. Then we have cosine. We know that cosine is adjacent over hypotenuse from our SOHCAHTOA. And the reciprocal of cosine is called secant. And that's just your your hypotenuse over your adjacent. So this one is abbreviated cosine theta. We know secant, we abbreviate SEC theta. And then finally, we have tangent, which we know is opposite over adjacent, and the reciprocal of tangent is called cotangent. And that would be just flipping it adjacent over opposite. Again, we call this one tan theta, and this one cotangent theta. We abbreviate COT. Okay? So, we're going to come down here. I'm going to focus on right triangles today. Tomorrow we'll do unit circle. But let's see. First off, if I need to find all 6 values of theta, I need to know which angle is theta. So this one's marked for me, so I can go ahead and use this angle as theta. Remember, theta cannot be my right angle. But if I'm going to find all these, I need the other side. So how am I going to find the other side? I'm going to use the Pythagorean Theorem. It's a right triangle. I can. Why not? So 8 squared plus b squared is equal to 2 rad 17 squared. Well, I know 8 squared is 16. 2 rad 17, I have to square the 2. 2 squared is 4. And rad 17 squared is 17. So I have 4 times 17. So 16 plus b squared equals, get my calculator here, 4 times 17 is 68. So if I move that 16, that means that b squared equals 52. And b equals, did I do that wrong? 4 times 17 is 68. I did do this wrong because 8 squared is not 16. It's 64. That's what I get for trying to do stuff while I'm sick. 64. So I'm not subtracting 16, I'm subtracting 64. And 68 minus 64 is 4. So if b squared is 4, then what does b equal? It equals 2. That's a lot nicer. Okay, so with regards to theta, what side is opposite? That would be 2. What side is adjacent? Well, it's one of these two, but it can't be the one that's the hypotenuse. So if 2 rad 17 is the hypotenuse, then 8 would be my adjacent angle. So, starting off with sine. I know sine is opposite over hypotenuse. I know cosine is adjacent over hypotenuse. And I know tangent is opposite over adjacent. So, opposite over hypotenuse, and simplify. So let's see, the 2's are going to cancel, so I have 1 over rad 17. Can't leave my answer as a radical on the bottom, so I'm going to multiply by rad 17 over rad 17. That's going to give me rad 17 on the top, and on the bottom, rad 17 times rad 17 is 17. That's what my sine of theta is. To find the cosecant, I just need to find the reciprocal. Now here's the deal with the reciprocal here. That would be the hypotenuse over the opposite. I could find the reciprocal here after I've simplified. But if you notice, if you were to write the reciprocal of that, you would have a radical on the bottom. So you'd have to simplify again. So why don't we go back to before we simplified and write it in that way, because I think we might be okay that way. So if I really took the opposite over the hypotenuse, or original, and I flipped that, that gives me the hypotenuse, which is 2 rad 17, over the opposite, which is 2. I get those two values to cancel, and the cosecant of theta is rad 17. Okay, let's try cosine of theta. Cosine is adjacent over hypotenuse. Well, adjacent is 8. Hypotenuse is 2 rad 17. Well, 8 over 2 is going to reduce to 4 and 1, so I have 4 over rad 17. Got to simplify that radical again, so I'm going to multiply by rad 17 over rad 17, and that gives me 4 rad 17 over 17. Last step, check to make sure these guys can't simplify. They can't, so that's what my cosine is. Again, after you've had to simplify something, don't find the reciprocal of that. It's going to give you more work. Go back to the beginning and flip your original one. So put the hypotenuse on top. That's 2 radical 17. And the adjacent on the bottom, which was 8. Then do your simplifying and things will be a lot more quick to get to your answer. So I have radical 17 over 4. Okay. And finally, tangent. Opposite over adjacent. Whoops, stepping ahead of myself. That's going to give me 1/4 when it reduces. Cotangent would be adjacent over opposite, which is 8 over 2 or 4. That one, because it doesn't have a radical, we don't have to be as specific about that one. Okay, here we go. Another triangle. Secant of theta is 13 over 5. That's what they're telling me. So I know secant of theta is 13 over 5. Well, I know one other thing, because I know that secant is the reciprocal of cosine. So if secant is 13 over 5, cosine is 5 over 13, the reciprocal. Goes both ways, just flip it. Now, I know from SOHCAHTOA that this is the adjacent over the hypotenuse. So if this is theta, hypotenuse is 13, adjacent is 5. How can I find that other side so that I can fill in my remaining values? Well, I can use the Pythagorean Theorem again. I know the adjacent is 5. I know the hypotenuse is 13. So 5 squared plus b squared, x squared, a squared, whatever you want to call it, we don't know it, equals 13 squared. Well, 5 squared is 25. 13 squared is 169. If I subtract 25, b squared is equal to 144. So what does b equal? It equals 12. So that opposite side is 12. So what's the sine of theta? That's going to be opposite over hypotenuse. Well, opposite is 12. Hypotenuse is 13. That's the sine. Cosecant is going to be the reciprocal, or the hypotenuse over the opposite. So that's going to be 13 over 12. Tangent is opposite over adjacent. Opposite over adjacent. Cotangent is going to be the reciprocal of that, or adjacent over opposite, which is going to be 5 over 12. Okay. So hopefully those are pretty easy to do. Let's go ahead and turn to the back side of our notes. Got a couple more to do here. Excuse me. Using our rules from way back when we did those special right triangles, that can help us find some different values on here. We can use our rules. Where in a 45, 45, 90 triangle, the sides are the same length, or the legs are the same length. The hypotenuse is equal to the leg times rad 2. And in a 30, 60, 90 triangle, your short leg doubled is the hypotenuse, and your short leg times rad 3 is the long leg. So right here, they're telling me I have rad 5 and rad 5, which tells me that we have a 45, 45, 90 triangle. So what is the hypotenuse? Well, if if I take a leg and I multiply it by rad 2, that gives me rad 10. And if I try and draw a tree for that, there's no pairs that can come out, so I'm just going to call it rad 10. Now it's asking for secant. I know that secant, from the other side, is the reciprocal of cosine. So if I can find the cosine adjacent over hypotenuse, all I got to do is flip it. So cosine of 45 degrees, which is either of those two because they're both 45, right? So I'm just going to call one of them theta. So the cosine of theta is adjacent, which is rad 5, over hypotenuse, which is rad 10. I'm not going to do any simplifying yet because I know that this isn't my answer. If it was my answer, I'd have to deal with the radicals. I'm not going to deal with the radicals any more than I need to, so I'm going to wait until I get the secant. So secant of theta is the reciprocal of this. That would be radical 10 over radical 5. And our radical simplifying rule says you can simplify anything inside with inside and outside with outside. Well, both of those numbers are inside a radical, so I can go ahead and treat this as though it's this. And 10 over 5 is 2. So the secant of 45 degrees is radical 2. Again, I started by just finding the cosine and then doing the reciprocal and simplifying when needed. Okay? All right, cotangent of 30 degrees. Okay, cotangent. I'm going to start off with tangent of 30 because I know tangent is opposite over adjacent. So it's going to be something over 10. So how do I find that something? Okay, sorry, I had a little interruption there. Where am I at? So I need to find this side over here. I actually don't need the hypotenuse for this one because it's not used in the tangent ratio, therefore it's not going to be used in cotangent. From my rule up here, the long leg is equal to the short leg times radical 3. So if this is equal to the short leg times radical 3, how can I find the short leg? Well, I can divide both sides by radical 3. So n is equal to, I'm going to give myself some room here because I'm going to have to simplify a denominator, or not simplify, rationalize. Multiply by radical 3, so I have 10 rad 3 over 3. That's the length of this side, 10 rad 3 over 3. So tangent is 10 rad 3 over 3 over 10. Cotangent of 30 is going to be adjacent over opposite. Whoops, I'm sorry, I'm reading ahead. So that's going to be 10 over 10 rad 3 over 3. Now that's just a confusing way to write it when you have a fraction in there. So I'm going to write this a little bit differently. I'm going to call this 10 divided by 10 rad 3 over 3. How do you divide things when you have a fraction? Well, you keep the first the same, change it to multiplication, flip the second one upside down. That gives me, if I call that 10 over 1, 30 over 10 radical 3. I can simplify this to a 3 and a 1, so it's 3 over radical 3. So the cotangent of 30 degrees is 3 over radical 3. Just got to do a little bit of simplifying to get that radical off the bottom. That gives me 3 radical 3 over 3. Those guys cancel. My final answer is radical 3. And that's what the cotangent of 30 degrees is equal to. Again, it's just the reciprocal of the tangent of 30 degrees. Okay? All right. Last problem. Use the given point on the terminal side of angle theta to find all 6 trig ratios. Now, this is on your quiz coming up, so you're going to want to know how to do this problem. So what I do is I go to the point they give me, and wherever that point is, whatever quadrant it is, you need to draw a line straight from that point to your x-axis. There's my x-axis right there. It's a very badly drawn line, but that's going to make a right triangle for you. I have a right triangle right there. If I were to pull that right triangle out, it would look something like that right there. Yeah, that's that exact same triangle. Now, in that triangle, the angle that is at the origin is always going to be your theta. So whichever angle is right at the origin of the graph, that's your theta value. And then the x-axis side is going to be the x value of that point. So that's rad 15. 7, I'm going to ignore the negative right now, but 7 is going to be the length of the other leg, and the hypotenuse is one you're not going to know. So you're going to have to use the Pythagorean theorem to find the hypotenuse. So if I use the Pythagorean theorem here, rad 15 squared plus 7 squared is equal to c squared. That gives me, excuse me, 15 plus 49 equals c squared. 49 plus 15 is 64. So c is equal to 8. So I have a triangle where I have a theta value right there. I have rad 15, 7, and 8. I need to find sine theta, cosecant theta. I need to find, I'm going to make myself a little chart like I had on the other side. I need to find cosine theta and secant theta, grouping them together with their reciprocals because that makes it easier for me. And I need to find tangent theta and cotangent theta. And now that I have a triangle, this should be pretty easy. So, sine we know is opposite over hypotenuse. Opposite is 7, hypotenuse is 8. That's going to be 7 over 8. The reciprocal of that for cosecant is 8 over 7. Now, something that I didn't look at beforehand, but I should before I get to the end of these, is I have an angle that is in the 4th quadrant. And if I remember, all students take calculus, or all students talk crap. In the 4th quadrant, cosine is the only thing that's positive. So in other words, sine is going to be negative, and tangent is also going to be negative. Reciprocal functions follow the function that they are a reciprocal of. So if sine is negative, cosecant is also negative. If tangent is negative, cotangent is also negative. If cosine is positive, secant is also positive. So these two are my only positive ones in that quadrant. Okay, so I've got my sine. Cosine is adjacent, which would be rad 15, over hypotenuse. No simplifying necessary. That's my cosine. Secant is going to be the reciprocal of this. So that would be 8 over rad 15. Do need to do some simplifying. Multiply by rad 15 over rad 15. That gives me 8 rad 15 over 15. Double check if you can simplify. I can't. So that's my secant. And then finally, tangent is going to be negative. Let's see. Opposite is 7 over rad 15, the adjacent. So, got to do some simplifying here. Multiply by rad 15 over rad 15. That gives me negative 7 rad 15 over 15. Nothing can reduce, so that's my tangent. And then finally, cotangent. This goes back to the other side where I was saying if I had to do some simplifying to get to here, it's actually easier to go back to the unsimplified fraction and flip it, because it'll save you from having to do some simplifying here. Because if I flip this, my answer, I'm going to have a radical on the bottom, I'm going to have to simplify. But if I flip this one, which means the same thing, my radical is already on the top, and I'm not going to have an issue. So I have negative radical 15 over 7. Now, as far as negative signs, I kind of wrote them a little bit different. Here I wrote it out front. Here I wrote it with the top. It doesn't really matter if you put it with the top, or if you put it out front, or if you put it on the bottom for that matter, as long as it's there. The only thing you can't do is put it on both the top and the bottom, because if you have one on the top and one on the bottom, you're making the fraction actually positive, because a negative over a negative makes a positive. I tend to like it just out front or on the top. That's just my default that I tend to put them there. Okay? All right, happy studying.